Question is, a long wire with a small current element of length 1 centimeter is placed at the origin and carries a current of 10 ampere along the x-axis. Find out the magnitude and direction of the magnetic field due to the element on the y-axis at a distance 0.5 meter from it. So here what is given? The current element is given. So current element dl is 1 centimeter. So convert into meter, 1 into 10 power of minus 2 meter. Okay. And current is given. Current I is equal to 10 ampere. So we have to calculate the magnetic field dB, which is at a distance 0.5 meters. So what is this? 0.5 is your R. Okay. So the formula for calculating the magnetic field dB is, since we have to calculate the magnitude of magnetic field, so it will be mu naught divided by 4 pi I dl sine theta divided by r square. Substitute the values here. We know that mu naught is 4 pi into 10 power of minus 7 divided by 4 pi. I is 10 ampere into dl is 1 into 10 power of minus 2 sine theta, the angle between dl and r, so you can say that it is 90 degree. Okay, so which will be sine of 90 degree divided by r square, so it will be 0.5 whole square. So when you do this calculation, you get the answer as 4 into 10 power of minus 8 Tesla. That is the magnitude of the magnetic field. Tesla is the unit for measuring the magnetic field. But we also know that the direction of magnetic field can be calculated as it is a cross product of the current element, that is dl, and the r, the distance. So let us calculate the direction of magnetic field. So the direction of magnetic field is dl cross r. We know that dl is along the x-axis and r is along the y-axis. So the unit vector representing along the x-axis, we know that it is I, unit vector I. Along the y-axis, it is the unit vector j. So I cap and j cap. So we are writing with respect to the unit vector along the x and y axis. So we can write it as delta xi, that is along the x axis, that is the current element. Okay, and this cross product of r is along the y into j. So I am writing this as delta x, okay, into y, okay, then multiplied by I cross j. Okay, I am just rewriting this as y into delta x, and we also know that the identity, that is I cross j, gives you what? The k vector, that is along the z axis. So I cross j, I am writing it as k, unit vector k. We also know that k unit vector represent along the z axis. So we can say that the direction of magnetic field is towards positive z axis or positive z direction.